Hello and welcome to Sleep Haven. Tonight we travel back to the very beginning, before the sun, before the planets, when our solar system was just a cloud of dust and gas drifting through the emptiness. Imagine particles slowly colliding and coming together over millions of years, creating order and setting the stage for everything that would follow. Take a deep breath, get comfortable, and let your mind wander through this cosmic journey. For an off-screen distraction-free experience, you can also listen on Spotify. Link is in the description below. Around 4.5 billion years ago, a small part of this cloud began to collapse under its own weight. Particles clung together, forming tiny clumps. Each collision, each new combination of dust and ice made the clumps slightly larger. Some of these grew into objects called planetesimals, which drifted through the forming disk, slowly accumulating more matter. Over time, these small beginnings would grow into the planets, moons, and smaller bodies we recognize today. At the center of this gathering, the largest clump became the sun. Deep inside, pressure and heat built until nuclear fusion started, transforming hydrogen into helium. Light and warmth began radiating outward, shaping the surrounding space and influencing the movement of other bodies. Around it, the leftover dust and gas flattened into a disk, spinning in a steady pattern. Within this disk, more clumps formed. Some became the rocky planets closer to the sun. Farther away, where temperatures were lower, clumps of ice and gas combined to form the larger outer planets. Not all objects became planets. Some stayed small, forming asteroids and comets. Others were caught by larger planets, becoming moons. These smaller bodies followed their own paths, interacting subtly with their surroundings. Over millions of years, these interactions helped the system settle into the patterns we observe today, creating orbits and alignments that would remain stable for billions of years. The formation of the solar system was a slow process. Dust and gas moved, collided, and merged. Planetesimals combined to form planets. Some were destroyed in collisions, while others survived to find their place in the sun's orbit. Belts of asteroids and distant icy bodies formed beyond the planets, adding complexity to the system. Each piece, from the largest planet to the smallest rock, contributed to the balance that defines the solar system. The asteroid belt, lying between the inner and outer planets, became home to countless rocky fragments. Farther out, beyond the outer planets, icy objects formed what we now call the Kuiper Belt. Comets occasionally travelled inward, tracing long paths through space. Each of these smaller bodies exists within the broader gravitational rhythm, moving predictably yet differently from one another, contributing to the intricate architecture of the solar system. As you imagine these early days, picture the dust drifting in space, slowly sticking together, forming clumps, forming planets. Picture the sun igniting, sending warmth and light across the spinning disk. Picture the planets taking shape, finding their paths, moons beginning to circle, comets tracing long, elegant curves. All of this unfolded over millions of years, driven by the fundamental forces of physics, gradually creating a system that would one day host life. As the solar system settled into its structure, the planets began their long journeys around the sun. Each one follows a path shaped by gravity and motion, tracing a route that continues over billions of years. You can picture it as a vast system of moving tracks, where every planet keeps to its own lane, guided by forces that remain steady and consistent. These paths are not perfect circles. Instead, they take the form of ellipses, stretched slightly along one direction. This pattern was described by Johannes Kepler in the 17th century. His work showed that planets move at different speeds along their orbits, travelling faster when they are closer to the sun and slowing down as they move farther away. This changing speed is not random. It follows a clear and predictable rule that helps maintain balance throughout the system. The inner planets, including Mercury, Venus, Earth, and Mars, travel along shorter paths. Because they are closer to the Sun, they complete their orbits more quickly. Farther out, Jupiter, Saturn, Uranus, and Neptune move along much wider paths. Their journeys take longer, but their motion follows the same underlying principles. Together, these differences in distance and speed create a stable arrangement where each planet continues its motion without crossing into another's path. Gravity is the force that holds this system together. It draws each planet toward the Sun, while the planet's forward motion carries it along its path. The result is a continuous curve, a balance between falling inward and moving forward. This same interaction governs the motion of moons around planets, creating smaller systems that mirror the larger one. Although each planet follows its own orbit, they are not completely independent. Over time, they influence one another through small gravitational pulls. These interactions can create patterns known as resonances, where the timing of one orbit relates to another. For instance, Jupiter's strong gravitational presence affects many objects nearby, especially within the asteroid belt, shaping their paths over long periods. Beyond the planets, countless smaller objects travel through the solar system. Asteroids drift along steady routes, while comets follow longer, more extended paths that carry them far from the Sun before bringing them back again. Some of these paths cross the orbits of planets, yet collisions are rare because of the vast distances involved and the regularity of their motion. Earth is part of this larger pattern. It completes one orbit around the Sun in a year, following a path that is slightly stretched rather than perfectly round. This variation affects how sunlight reaches the planet over time, contributing to the cycle of seasons. The steady return of these patterns provides a consistent framework that life on Earth depends on. If you could look down on the solar system from above, you would see layers of motion unfolding at different speeds. The inner planets circle quickly, while the outer planets move more slowly along wider arcs. Moons revolve around their planets, and smaller bodies trace their own routes between and beyond them. Each path is distinct, yet all are connected through the same set of physical laws. These movements are not completely fixed. Over very long stretches of time, small shifts take place. A planet's orbit may change slightly in shape or position. These changes happen gradually, influenced by the combined pull of other bodies. Even so, the overall structure remains stable, allowing the system to continue in a consistent and predictable way. When we take a step back and consider these motions together, a clear pattern emerges. Each orbit fits into a larger framework where distance, speed, and gravity work together. Nothing moves at random. Every path reflects a balance that has been maintained over immense periods of time. As the planets move along their paths, they are accompanied by a wide range of smaller objects. These include moons, rings, asteroids, and distant icy bodies. Each follows its own route, adding detail and structure to the solar system beyond the main planetary orbits. Let us begin with moons. These natural satellites circle planets in a way that reflects the larger motion of planets around the Sun. Some moons are large enough to have complex surfaces, with mountains, valleys, and signs of geological activity. Others are much smaller, with uneven shapes that hint at a history of impacts and fragmentation. Despite these differences, they all remain linked to the planets they orbit. Earth has a single moon, one that has been observed and studied for generations. It moves around our planet in a regular cycle, changing its appearance as sunlight reaches it from different angles. This cycle has long been used to mark the passage of time. The moon also affects Earth in a measurable way. Its gravitational pull influences the oceans, creating tides that rise and fall in a steady pattern. In other parts of the solar system, moons are far more numerous. Jupiter, for example, has a large collection of them. Among these are Io, Europa, Ganymede, and Callisto, each with its own distinct features. Io shows constant volcanic activity. Europa is covered by a thick layer of ice. Ganymede is the largest known moon in the solar system. These moons not only orbit Jupiter, but also affect one another through their combined gravitational influence. Their interactions shape both their motion and their internal structure over time. Saturn also hosts many moons, along with a feature that sets it apart. Surrounding the planet is a broad system of rings. At first glance, these rings may appear solid, but they are made up of countless individual pieces. These range from fine particles to larger chunks of ice and rock. Each piece travels in its own orbit around Saturn, yet together they form a flat, layered structure. Closer observation reveals patterns within the rings. There are gaps, divisions, and areas where particles are more densely grouped. Many of these patterns are shaped by the gravitational pull of nearby moons. These moons help maintain the structure of the rings, guiding the movement of particles over time. The exact origin of the rings is still being studied. One idea suggests that they formed from material that never combined into a single body. Another possibility is that they are the remains of a moon that broke apart long ago. Regardless of how they formed, the rings show how large numbers of small objects can move in an organized way under the influence of gravity. Beyond moons and rings, there are many smaller bodies traveling through the solar system. One of the most familiar regions where these objects are found is the asteroid belt, located between Mars and Jupiter. This region contains a large number of rocky bodies, each following its own orbit around the Sun. They are spread out across a wide area with significant distances between them. Asteroids come in a variety of forms. Some are composed mainly of rock, while others contain a higher proportion of metal. Their shapes are often irregular, shaped by earlier collisions that broke larger bodies into smaller fragments. Although impacts still occur, they are infrequent due to the vast space separating these objects. Comets follow a different pattern. Their paths are often stretched out, carrying them far from the Sun before bringing them back again. As a comet approaches the inner solar system, heat causes some of its icy material to turn into gas. This creates a glowing cloud around the comet, and a tail that extends away from the Sun. These tails can grow to enormous lengths, though they are made of very thin material. As the comet moves away again, this activity fades. Over repeated journeys, a comet can lose material, gradually changing its size and structure. Some may eventually break apart or become inactive, leaving behind trails of debris that continue along similar paths. Far beyond the orbit of Neptune lies the Kuiper Belt, a region filled with icy objects moving along distant paths. Among them are dwarf planets such as Pluto. These bodies orbit far from the Sun, where conditions are much colder. Their motion is slower, but they remain part of the same overall system. Beyond this region lies an even more distant area that surrounds the solar system. It is thought to contain a vast number of icy objects spread across a large volume of space. This distant region is believed to be the source of many long-period comets that occasionally travel inward. Although these objects are difficult to observe directly, their presence can be inferred from the paths of the comets that reach the inner solar system. All of these smaller bodies contribute to the overall structure of the solar system. They add layers of motion, each one following its own path while remaining connected to the whole. Some stay close to planets, while others travel across great distances. Together, they create a system that is both varied and interconnected. These objects also influence one another over time. A passing asteroid may shift slightly as it moves near a planet. A moon may experience internal changes due to gravitational interactions. A comet's path may adjust after repeated passes through the inner regions. These changes are usually small, but over long periods they can become more noticeable. When viewed as a whole, the solar system is more than a collection of planets. It includes many layers of motion, from large bodies to small fragments. Some regions contain many objects, while others are more sparse. Each part plays a role in shaping the structure we observe today. If you imagine observing this system from a distance, you might see planets moving along their paths, surrounded by their companions. Rings form thin bands around certain planets. Asteroids occupy wide regions between major orbits. Comets travel along extended routes, appearing and disappearing over long periods. Each object moves in a way that can be understood and predicted. So far, we have explored the structure of the solar system and the many objects moving within it. Now we turn to the principles that make all of this possible. Behind every orbit and shifting path is a set of physical laws that guide motion in a steady and predictable way. The most important of these is gravity. Every object with mass pulls on other objects. The strength of this pull depends on how much mass each object has and how far apart they are. The Sun, which holds most of the mass in the solar system, has the strongest influence. It pulls the planets toward it, while their forward motion keeps them from falling straight inward. This combination creates the curved paths we observe. This balance between attraction and forward motion keeps planets in orbit. If a planet were not moving forward, it would fall directly toward the Sun. If gravity were not present, it would continue in a straight line into space. The path we see is the result of both effects working together. The same idea applies to moons moving around planets and to smaller objects travelling through the system. Momentum also plays a key role. Once an object begins moving, it continues in that direction unless a force changes its motion. In space, where there is almost no resistance, this effect is easy to see. A planet keeps moving along its path, adjusting only when influenced by gravity. This is why the overall motion remains consistent over long periods. Another important concept is angular momentum. This describes how objects move when they rotate or orbit. When the solar system first formed, the cloud of material that would become the Sun and planets was already in motion. As it contracted, that motion became more organized, leading to the rotating disk from which the planets formed. Today, that same principle continues to shape how objects move around the Sun. Energy is also part of the picture. Objects in orbit constantly shift between two forms of energy. One is related to motion, and the other to position within a gravitational field. As a planet moves closer to the Sun, its speed increases. As it moves farther away, it slows down. This change in speed reflects an ongoing exchange between these two forms of energy, helping maintain a stable pattern. Although the Sun provides the dominant pull, the planets also influence one another. These effects are usually small, but over long periods they can lead to noticeable changes. In some cases, they create repeating patterns that link the motion of different objects. These patterns, known as resonances, help organize the system and reduce the chance of instability. Tidal forces add another layer of interaction. These occur when gravity pulls more strongly on one side of an object than the other. This difference can stretch and slightly reshape the object. On Earth, tidal forces affect the oceans. In other parts of the solar system, they can generate internal heat within moons, leading to changes beneath their surfaces. Small adjustments are always taking place. An object passing nearby may slightly alter another object's path. Over time, these small changes can accumulate. Even so, the system remains stable because these variations tend to balance out rather than grow unchecked. The solar system has developed in a way that allows it to absorb these shifts while maintaining its overall structure. The distribution of mass also shapes how everything moves. The Sun contains most of the system's mass, which is why it plays a central role. Planets, though much smaller, still have enough mass to influence nearby objects. Smaller bodies contribute in more limited ways. This layered arrangement creates a system where larger objects guide the motion of smaller ones. Over very long periods, the combined effect of all these forces leads to gradual change. Orbits may shift slightly. Rotations can adjust. Some objects may move onto different paths. These processes unfold over millions or billions of years. From our perspective, the system appears steady, but it is always evolving at a pace that is difficult to notice. The same physical laws that shape our solar system apply throughout the universe. Other stars have their own systems, formed and guided by the same principles. By understanding how these forces work here, we gain insight into how similar systems might exist elsewhere. After exploring the structure, motion, and forces that shape the solar system, we can bring the focus back to a simple question. What does all of this mean for us here on Earth? Our planet is only one small part of a much larger system, yet its position and movement are closely tied to the conditions that allow life to exist. Earth orbits the Sun at a distance that keeps temperatures within a range where liquid water can remain stable. The path it follows is not a perfect circle, but the variation is small enough that the overall pattern stays consistent. As Earth moves along this path, the amount of sunlight it receives changes in a steady cycle. This works together with the tilt of Earth's axis to shape the seasons. That tilt is a key detail. Earth spins at an angle rather than straight up and down. Because of this, different parts of the planet receive more direct sunlight at different times of the year. When one hemisphere leans toward the Sun, days become longer and temperatures rise. At the same time, the other hemisphere experiences shorter days and lower temperatures. This alternating pattern repeats year after year, forming a reliable cycle that living systems have adapted to. At the same time, Earth rotates on its axis, completing one full turn in about 24 hours. This rotation creates the familiar pattern of day and night. As the planet turns, each region moves into sunlight and then back into darkness. This daily cycle influences temperature, weather, and the internal rhythms of living organisms. Plants, animals, and humans all respond to this regular change in light. The moon adds another layer to this system. Its orbit around Earth helps stabilize the planet's rotation over long periods. This contributes to the consistency of Earth's tilt, which in turn supports long-term climate patterns. The moon also drives the rise and fall of ocean tides. These shifts follow a predictable rhythm and have shaped coastal environments over time. Earth's atmosphere plays an equally important role. It interacts with incoming sunlight, absorbing some energy and reflecting the rest. This process helps regulate surface temperatures and prevents extreme swings. Without it, conditions on Earth would be far less stable. The atmosphere works together with Earth's position and motion, forming an environment where life can develop and continue. Looking at the other planets helps put this into perspective. Some orbit much closer to the Sun, where surface conditions are far hotter. Others lie much farther away, where temperatures remain very low. Some have thick atmospheres that trap heat, while others have almost none. These differences show that Earth's conditions are the result of several factors working together rather than a single cause. When viewed as a whole, the solar system provides the larger framework in which Earth exists. The Sun supplies energy that reaches every planet. Each planet follows a stable path, and smaller objects move within the same structure. Within this setting, Earth has developed its own systems, including oceans, weather patterns, and life itself. These patterns are not unique to our solar system. The same physical laws apply throughout the universe. Around other stars, similar systems may form, with planets moving in comparable ways. Some of those planets may exist at distances where conditions allow for processes similar to those on Earth. By studying our own system, we gain a better understanding of how these possibilities might arise elsewhere. At an even larger scale, the solar system itself is in motion. It travels through the galaxy, following a path around its center over extremely long periods. This movement is not something we notice in everyday life, but it is part of the same set of principles that govern everything from planetary orbits to the structure of galaxies. If you step back and picture it all together, you can see how these layers fit into one another. Planets orbit the Sun. Moons circle their planets. Smaller objects move along their own paths. At the same time, Earth rotates, circles the Sun, and supports a wide range of life on its surface. Each level of motion connects to a larger one. These repeating patterns also shape how we understand time. The rotation of Earth defines the day. Its orbit around the Sun defines the year. The motion of the moon helps mark the month. For thousands of years, these cycles have guided how people measure time, plan activities, and observe the natural world. In the end, Earth is not separate from the rest of the solar system. it is part of a connected structure, shaped by the same forces and following the same principles. The conditions that allow life to exist are not random. They come from a combination of position, motion, and physical laws working together over long stretches of time. As we close this exploration, you can hold a simple image in mind. The sun at the center, planets moving along their paths, moons and smaller bodies, adding detail to the system, and among them, Earth, turning steadily as it travels around the sun, supporting life in many forms. This is the larger setting we are part of, a system defined by motion, guided by consistent laws, and continuing over immense spans of time. As these patterns carry on, they provide the structure within which everything on Earth takes place. Thank you for allowing me to guide you into rest tonight. I hope this episode helps you relax and drift into a restful sleep. If you enjoyed it, please subscribe to the channel to join us for future episodes. Sharing this podcast with friends or loved ones can help them find calm and rest as well. Sleep well, and may your night be peaceful and your dreams gentle.